Okay, thank you, Jim. How's everybody doing today? All right, so I want to see a show of hands. How many people here know you have a combustible dust issue in your workplace? It's good. I gave one of these not too long ago, and nobody raised their hand. I said, well, why are you here then? People were asking about salt and sand, things that are not combustible, but I gave them the presentation anyway. Well, it's good to be here. As you mentioned, my name is Brian Edwards. I'm with Conversion Technology. I've been in safety and environmental consulting for about 13 years. I've dealt with a lot of process safety management and then fire protection and combustible dust issues. Being from Georgia, we have a lot of wood products industry. So, just over that time, we dealt with a lot of fire protection. And then the buzzword combustible dust came up, and so everybody says, well, it's combustible dust, but I think a lot of people just know it as fire prevention because, in the wood products industry and then food and a lot of industries that I've dealt with, it's just always around. It's a fire issue, but it's also a deflagration and explosion issue too. This is a pretty big topic, so I could very easily spend 2 days talking about combustible dust issues. But today I'm going to give kind of a broad brush scope over everything about combustible dust. Just give you a brief introduction, discuss how to identify combustible dust hazards in your workplace, how to ensure facility safety. Then I'll get into a little bit of the regulatory issue. I'll talk about where OSHA stands and then give you a little bit of a status on where OSHA is going with the combustible dust rulemaking. So just in general, combustible dust is a major issue in industrial facilities that generate this product. The Chemical Safety Board said that of the top 5 worst industrial accidents that they've investigated, 3 of those involve combustible dust. In 2008, following an explosion in Savannah at Port Wentworth Imperial Sugar Plant, OSHA reinstituted a national emphasis program that helped them conduct inspections under the program and provided industry guidance. In October 2009, OSHA came up with an advance notice of proposed rulemaking where they said they're going to work towards creating a combustible dust rule. And some states have went ahead of OSHA, such as Georgia and California, and they've instituted their own rules about combustible dust safety in the workplace. Just in general, what do we mean when we talk about combustible dust? We're really talking about any particulate solid material that can present a fire hazard when dispersed in the air. It says regardless of size or shape. This is according to NFPA. Traditionally, if it's a combustible particulate solid and you throw it in the air and it sort of creates a cloud, it floats around, it stays in the air, then you might have a combustible dust. This is typically dry foods, wood, plastics, textile, organic materials, and even some metals such as aluminum, magnesium, things like that. And why we're really concerned about it is because when you disperse it in the air and you have a thick enough dust cloud, if you ignite it, it acts much like a vapor cloud. So people think of solid materials as burning different than, say, vapors or liquids. But if you disperse dust in the air, it can have a flash fire just like a vapor cloud. And the reason that happens is because the rate of combustion of a material significantly increases as you get smaller particles. And what happens is, if you remember the fire triangle, you have to have fuel, you have to have oxygen, and you have to have heat. So if you, say you had a log, all the wood particle, that fuel that's in the middle of the log, it's not touching oxygen. So you're missing part of the fire triangle. Well, if you turn that log into sawdust, you disperse it in the air, well, then all that fuel is touching oxygen, so all of that fuel can burn at once. You don't have to burn through the outer layer of the log to get down to the center of it, so it burns. Basically, all of it will burn in an instant, just in a flash. You have a flash fire, and that's the danger here. And one of the largest dangers is that you can have this dust can accumulate in overhead and hidden areas. And the stuff that accumulates in those high areas is often the finest material. It's the stuff that's lightest, the stuff that hangs in the air the easiest. So it's going to accumulate in these hard to reach hidden areas. And you can have a primary explosion, say in a single piece of equipment, say a dust collector or a boiler explosion or something that sends a shock wave through, and it can disperse this dust cloud. And then basically the entire room can be dispersed with the dust cloud and this hazardous atmosphere. And then if that ignites, it spreads throughout the entire facility. So you take something that maybe was isolated in a single piece of equipment, it disperses dust that's accumulated in the facility, creates a secondary explosion that could decimate an entire plant. I mentioned that the National Emphasis Program came out in 2008, but this has really been an issue for a long time. The first actual recorded combustible dust incident happened in 1785 in Italy. There was a boy who was stirring flour by the light of a lamp, and he created a cloud, and the lamp ignited the flour, and it destroyed a bakery. But this year, some examples of incidents just this year. This was in British Columbia at a sawmill. And this is the second large explosion that happened at a sawmill in this area of Canada this year. This most recent one, there were 2 killed, 22 injured. And the first incident, the other explosion in British Columbia, was similar. You know, you had multiple fatalities and a lot of serious injuries. This particular incident, a resident 2 kilometers away felt his house shake and vibrate because of this explosion. And one interesting thing, I don't know how interesting any event like this is, but one thing to note is that change of material was probably a large source of this, this incident. I don't know how many people are familiar with sawmills and planer mills, but typically when you have a sawmill, you're processing green lumber. So it has high moisture content. It clumps together. It doesn't really, that green sawdust doesn't form a dust cloud in the air. And the high moisture content means that it doesn't really have a flash fire potential because it has so much moisture in there. You have to kind of evaporate off the moisture before it burns. So you don't have the flash fire like you do, say, in a planer mill, which is after it goes through a kiln, you dry it, then you create this fine wood shavings that's a lot more combustible. Well, in Canada, they've had an issue with their forests. They've had a beetle infestation, so there's been a lot of killed trees. And so a lot of the wood industry has said, okay, well, let's try to do something with these dead logs. Well, they've sat out there, they've dried, they got lower moisture content down to where what you'll typically see in a planer mill. And well, so the sawmills, which really haven't protected themselves like a planer mill would for fire protection, well, they started processing this low moisture content wood, and because of that, because they weren't really ready for the dust explosion incident or issue, they've had 2 recent explosions. So it's just an indication that you really need to pay attention to material, and when you change your materials in your plant, something that wasn't a hazard before all of a sudden becomes a hazard just because of something such as moisture content. We'll get into some basic, I guess, definitions. How many people have ever heard of the word deflagration? So it seems like a pretty knowledgeable group here today. Just in general, when we talk about deflagration, you can think of a flash fire. So it's just, imagine it's a fireball that consumes a dust cloud. So it just, it flashes through an area. A dust deflagration, it goes very fast. So you're still talking, less than a second. It can move through an entire area. It goes slow, a little bit slower than, say, a vapor cloud. Vapor clouds go quick. Dust clouds are a little bit slower, but it's still within milliseconds and less than a second. Still not enough time for somebody to get out of the way of these deflagrations. So how did these occur? So what you need small enough particles. So you need fuel. So these are combustible particles that when you throw it in the air, it can be, sort of floats around, can create a cloud. Then you need that fuel to actually be in a cloud in a sufficient concentration to propagate that flame front. So if imagine just a little speck of dust, when it ignites, it has to be close enough to the next piece of dust to ignite it, and it creates that flash fire. Next, you need available oxygen, and then you need some type of ignition source. So you need some type of energy or heat source. When deflagrations occur just in the open air, they still generate a pressure wave. So they generate a lot of pressure just because overheating gas and all this. So if you put that deflagration inside an enclosed area, like this room here, or inside a piece of equipment like a bag house or some dust collector or bin, well, that all of a sudden this room or that vessel can't contain the pressure that's generated when this flash fire occurs. And that's when you'll have an explosion. Typically, I like to think of deflagrations and explosions kind of cause and effect. So you have a deflagration that occurs inside a vessel, and that is the cause of the explosion. So when the explosion technically is a rupturing of an enclosure. So when that enclosure ruptures, that's an explosion, and it releases that pressure outside. So a deflagration occurs inside an enclosed area, and it causes an explosion. Typically, industrial dust explosions can create chain reactions. So they can go through areas in the plant. So it might start in this room. You have an explosion, it blows out a wall into the next room, and it blows out a wall, and it goes through. You can also have this happen in the process itself. So, for instance, you have a cyclone that may be exhaust to a bag house. You can have an explosion occur in the bag house, and the flame front will actually go back upstream against maybe the flow of air and can travel back to the cyclone. I've actually seen this several times. One time I was in a plant, they had one bag house that was tied to two separate cyclones on two different lines. It was a wood pellet mill. They had a deflagration occur in one cyclone. The flame front went to the bag house exploded, and it went back upstream to the other cyclone, and also upstream into the process area where they had some connections going inside the pellet mill itself around equipment. And often these secondary explosions, this transfer of these explosions through the process or through areas, are the most deadly. As I mentioned earlier, OSHA has put out an advance notice of proposed rulemaking, but they don't have a rule yet. So really, you can't afford to wait on OSHA before you address these hazards. So I'm going to go through a little bit today of what should you do at your facility to address combustible dust hazards. So in general, the first step is to really understand what type of hazards are present. So you can conduct a facility dust hazard analysis so you understand how severe are the hazards in our workplace. Next, you'll want to install engineering controls and at the same time implement administrative controls such as housekeeping and maintenance. And also make sure you implement hazard communication and training. So how do you really identify the hazards in a workplace? I'm going to go through the steps really that you need to do to identify where combustible dust hazards might exist and to sort of quantify those. So really the first step is you want to know what type of dust you're handling. You want to know what dust is combustible, what dust isn't combustible, and sort of a relative value of how dangerous are the different dusts that we're dealing with. Next, you want to sort of itemize all the processes where this dust is handled, where it's generated, where you process it. Then you want to look at the open and hidden areas, just the rooms and the facilities, and say, okay, well, where is dust accumulation present? And finally, you also look at ignition sources. And then finally, you want to kind of rank that and say, well, how dangerous are these different places? Because not every hazard is equal. And as I'll describe later, addressing this can be very expensive. So you want to make sure that you take care of the most dangerous aspects first. And then, maybe come up with priorities. So you'll want to try to come up with some risk ranking. Okay, so first step is identifying the types of combustible dust. So you really want to look at all processes to see what type of dust are handled. Do we handle powders? Do we add components, or do we create powders? Or is our dust just sort of a byproduct of what we do? Or are we, is it coming off grinders? Is it coming off milling? Is it sort of not really main part of our process? If you're somebody that handles powders, you want to look at MSDSs, contact the vendors and manufacturers, see if they have any data on the dust. If they don't, if it's a common material, say if it's you're dealing with flour or sugar, you might be able to look look online, look in textbooks, look in some of the NFPA standards. They have some of this dust explosion parameters. But more often than not, you're not going to be able to find, you might not get data from a vendor. You're not going to have, that data readily available. Not everybody's, handling something as prevalent as flour or sugar or wood dust. So you might have to go out and get your own data and find out. So I'm going to discuss a little bit of the tests and how they're used. There are a number of labs where you can send your dust to be tested to see, okay, well, how dangerous is it? Some of these tests here, the first three I talk about deal with how easy are they to ignite. So it's about ignition sensitivity. And the next test I'll talk about deal with how severe is an explosion if it occurs. So we talk about minimum explosive concentration, and what that is, that tells you how thick does a dust cloud have to be in order for there to be an explosion or deflagration. In general, if you're familiar with industrial hygiene and IH standards, you're talking about dust exposure normally into milligrams per cubic meter in the air. So that's stuff that you might not even see this dust. When we're talking about explosible concentrations, we're talking about grams. So like 1,000 times higher than what you would want to see just from your respiratory standing. So because of that, typically, you're not just generally operating at a minimum explosive concentration in the area. But what can happen is inside process equipment, you can be at that level. Or if you have that dust disturbed in the air, you can reach that level. Actually, the NFPA states that if you have a surface area in a room at 5% of the surface area has 1/32 of an inch of dust on it, that's enough dust that if you disturb it, it could create a dust cloud at the MEC over the 10 foot high over the entire surface of the room. So that's really how little dust it takes to get up to that concentration. The next two are minimum ignition temperature and minimum ignition energy. Help you determine, okay, well, what surface temperature might ignite a dust cloud? What type of energy might ignite a dust cloud? The Pmax and the KST tell you how strong is an explosion that occurs here. So you might have something like aluminum that's is very powerful explosion, almost getting close to detonation. Or then you might have something that's not quite as strong as aluminum. Say sugar. Some of these, you might have seen this KST value before, and OSHA and NFPA say that, okay, the KST, you have weak, you have moderate, you have strong explosions based on how high that KST is. I don't go into that here because if you look at NFPA and OSHA, it ranks sugar as a weak explosion. But if anybody's ever seen pictures of imperial sugar, that didn't look like a weak explosion to me. So I don't really classify it that way, but you might have seen it from OSHA or from someplace else as the weak and moderate and strong explosions. I say that if you have any value of a KST or Pmax, it's still a flash fire as an explosion hazard, and you need to address it. Next step you want to do is you really want to sort of itemize and understand where is this dust being handled, where is it being generated, what type of processes am I talking about. So really look through your facility, come up with a checklist, deal with anything like particle size reduction equipment. That's going to be hammer mills, it's going to be hogs, chippers, any grinding type operation. Those create dust, and they also are high likelihood ignition sources. Also, you want to look at bins and tanks and silos, because when you're filling a bin or when you're filling a tank, that's one of those likely times where you might actually have an explosive dust cloud in the void space in that bin. So as you're putting solid material in there, that lighter material still fills that space, so you can have explosions there. Also look at dryers and ovens. Those can ignite and create burning embers and spread them downstream. Look at dust collectors. Again, you almost always have that explosive concentration inside a baghouse or dust collector. Also look at conveyors, screw augers, bucket elevators. All those are areas where you can have ignition sources. You can have overheated bearings that can be transferred downstream. And then look at sifters, screens, classifiers, anything that creates that dust cloud inside the piece of process equipment. All right, then after you've looked at the individual process equipment, you want to spread out and look at just the facility in general. You know, look at the different work areas, the environments inside the facility where dust can accumulate. You really want to pay special attention to those hidden areas, you know, where people frequently don't visit, maybe where housekeeping doesn't get to every day. You know, so you really want to look at overhead piping and beams, drop ceilings, any interior overhead surfaces like control rooms or mezzanines, because those are areas you might not realize it, but there might be a significant volume of dust up there. If it gets disturbed, then the entire work area could become, an explosive environment. So any housekeeping you do, you want to make sure you look at all the areas, not just, kind of what you see on your day-to-day operations. Make sure you go up there, look on top of control rooms and on rafters and in pipes. And you also want to look at areas where dust might be released at a large quantity because of upset conditions. I was at a bakery, just a two-line bread bakery, and inside during your normal day-to-day operation, it looked spotless. So over by the oven, you saw no dust accumulation at all. But as we start talking, I found out that about once a year they would blow out a conveying line and just spew flour into the bakery within about 30 feet of the dryer. So if you keep doing that, you need to look at areas where, okay, normally we don't have this dusty environment, we don't have dust accumulation, but if we had a rupture of a pipeline, or if we had something go wrong in here, we could generate an explosive atmosphere because of creating a dust cloud. All right, once you know where you might have a dust cloud present, you might have a dust cloud, say, inside pieces of process equipment, or you might have it inside a work environment. You want to look at, what type of ignition sources do we have in that area? So some of the common ignition sources are, say, friction, any moving parts, any metal on metal contact. If it's not properly maintained, not inspected, not cleaned, it can generate heat, and that's a very common source of ignition. So maybe in a conveyor, you'll have a piece of material get hot from a bearing, and that burning ember is transported downstream. It gets picked up in a dust collector, and there's an ignition source. Also, another potential source is smoking. Hopefully, people aren't smoking in dusty environments, but you'd really be surprised. I've seen people, one of our clients went to a sawmill and they allow people to smoke in a sawmill. Next is static electricity. This is one that a lot of people, I guess, sometimes they'll overlook, but really, anytime you're conveying powders or particulates in a ductwork, it generates a lot of static electricity. And you might not think static electricity is that dangerous, but just the shock you get, say, if you're in a dry, cold wintertime, when you hit a doorknob, that's enough energy to ignite most dust clouds. That could generate, maybe 50 millijoules. And say sugar, like powdered sugar, that's 5 times enough energy to ignite a powdered sugar cloud. And also, some of the biggest issues are when you're conveying, say if you're offloading from a tanker truck and you don't have that grounded, you wouldn't transfer flammable liquids without grounding from a transfer truck. So you still don't want to do that. You don't want to do that with dust either, or particulates. Also, another major ignition source is hot work. I know most people probably have a hot work permit program in place, but I've seen a lot of hot work permits that don't address dust. They might address traditional combustible materials. They might say, okay, you got to move cardboard boxes away, or you got to move papers, you got to move flammable vapors or liquids. You can't have a gas tank near where you're doing hot work. But a lot of times people forget, you really need to wipe down walls. You need to clean all that dust off the area around where you're going to be doing hot work. Another issue is forklifts. If you're working in a dusty environment where you could generate a dust cloud, and you want to make sure that the fork truck you're using is properly rated for that. So you'll see trucks will be DE or EE or EX rated forklifts. Some other ignition sources, really First, you have just the process equipment itself. So up here we have a dryer that it heats up material. So you could have any sparks that might be transferred downstream could be an ignition source. Then here's this is a hammer mill. So we're talking about particle size reduction equipment. So you got something that's violently grinding up materials. If you get one of those blades loose, or if you get a foreign object in there, that's metal on metal contact. It sparks, or you could send a blade. Might be transferred downstream, and that's a common ignition source. And that's why whenever you have a pneumatic conveying line after a hammer mill, they always require spark detection and suppression systems downstream because they're just always generating sparks. I've heard sawmills say that even just a wood pine knot is hard enough to spark off a hammer mill. Also, you want to look at electrical sparks and arcing. If you have a potentially dusty environment, you need to have it electrically classified. Classified as a hazard location, have dust height or dust ignition proof equipment there. Also, you want to look at potential open flames, space or radiant heat. So if you have any space heaters or radiant heat, say if you have hot surfaces in an environment, or if you have lighting that might not be protected, those can all be ignition sources. All right, the next step, once you've identified, okay, where could a dust cloud be present, inside a process or inside the work area, and you've also identified, okay, well, what are the potential ignition sources? You want to determine sort of the likelihood of those being present. So what's the likelihood of there being a dust cloud and an ignition source in this area? And also, wherever you have these potential for, explosive, for dust cloud, or anywhere you have potential for dust accumulation, you want to look, well, what could be the effects of a deflagration or a fire in that area? You really want to look, well, how, is it an occupied area? Is it close to other critical processes? Is this piece of equipment maybe where we have a high likelihood for dust cloud and a high likelihood for an ignition source? Is it close to other pieces of equipment that are important? And so you want to look at the severity of, say, if there's a dust incident here. I'm about to show you a table. It's going to look a little bit overwhelming when you first see it. So I'm just going to briefly go through it today. But if anybody wants to maybe get a copy of this presentation, if you want to talk to me a little bit more about this, let me know afterwards. But this is, does anybody here operate under, say, process safety management? Then you might be familiar with, say, a process hazard analysis. And this is essentially what this is a what if. It's a way of us determining, well, how dangerous is a particular incident. And that way you can come up with priorities. I saw something not too long ago. It was from OSHA. I mentioned OSHA is coming up with a rule. They said that some of the average facility to come into compliance with, say, NFPA regulations or OSHA's proposed rule might be looking anywhere from, say, $350,000 up to over $1 million, depending on the industry. Like some, paper industries might be looking at over $1 million just to comply with, proposed combustible dust rule. So when you're looking at that type of volume, I know it's very hard for you to take that up to management and say, okay, write me a $500,000 check. So what this table does is allows you to prioritize the risk and your recommendations. That way you can say, okay, well, let's come up with, say, maybe a 5-year plan. Let's address all the things that are almost, extremely high hazards. But I'll go through what it does. And this was one we did for, say, a wood pellet mill. So you come up with the what if scenario. So, okay, what if there's a fire in the cyclone? You talk about, okay, what are the causes, what are the consequences? And you make that into severity and likelihood. And then the combination of how severe it could be and what the likelihood is helps give you what's called a risk ranking. Then you want to talk about safeguards and come up with some recommendations. For instance, this one, we had a severity of 4 from a deflagration for an explosion in a cyclone. We said, well, how can we reduce that severity? A 4 basically meant that there's potential for fatalities. We said, well, add explosion rupture panel on that cyclone. And well, because it was low likelihood, it had not too high of a priority. This was a cyclone that was located, 35 feet in the air. and it wasn't tied to any ignition source. So we're able to give it a low likelihood. But anyway, I know this is probably a lot to take in right now, but like I said, if you want to get a copy of this presentation, feel free to come and ask me after the presentation, and I'll be more than happy to sort of explain a little bit more what we're actually doing here. But just in general, what you want to do, the sort of takeaway from this, is that it's important to sort of prioritize how you address combustible dust hazards. So you're going to have some pieces of equipment that might require, retrofitting, or you might even have to replace a baghouse. And then there might be some other things, just increase housekeeping or do a better job. So you want to come up with priorities to see how can you get the risk and the hazards down the quickest at your plant. All right, once you understand the hazards, well, I'm going to briefly go into some of the things you can do to help control those hazards. Once you've done your hazard analysis, you know what type of hazard you have at the plant. Here's some of the things you can do to go with it. Honestly, this is something that I could probably spend a day talking about, all controlling these hazards. So I'm just going to kind of hit, the high points, go through them relatively quickly. Talk about engineering control, administrative control, and also hazard communication and training. So first I'll talk about primary engineering controls. And when I say primary, what that means it's controls that are used to just prevent a dust explosion from happening in the first place. The easiest way to be safe is just to not let it happen. So what you want to do is you want to have fugitive dust control. This means, just keep dust out of the air. Keep it from accumulating in the environment. You do this through good dust collection, good housekeeping, and just tight equipment. If you have conveying lines and you see sources of leaks of dust in your processing line, try to address them. See, is there a different way we can handle this material so we don't have to have, a person out there full-time doing housekeeping? Are there ways that we can get this better? And then also another primary control is ignition source reduction. So if you don't have ignition sources, you can't ignite a potential dust cloud. So you do this through electrical classification. If you could have a potential dusty environment, make sure all the electrical equipment is maintained properly and it's rated for the area, so it's dust-tight equipment. Make sure all your conveying lines and equipment that are handling dust are bonded and grounded. Use properly rated industrial trucks. And if you're handling a lot of particulates, if you're moving them a lot, you want to try to get foreign object removal. So have magnets, screens, gravity separators to keep those foreign objects that could be ignition sources inside the moving string, keep them out. All right, now we'll talk about secondary engineering controls. These are controls that you use. Okay, that deflagration started. Okay, the primary controls failed and there's a fire started. It might have just the very first spark of a fire, but it started. So how do we minimize the effects of that? So some of the common controls are explosion suppression. So what happens is as soon as that deflagration starts, as soon as that pressure just starts to increase, say a vessel will have a pressure transducer. It will detect that increase in pressure and it will flood the vessel or flood the area with a suppressant, say sodium bicarbonate, that prevents that deflagration to growing to a large size. And also another method is explosion venting. So you might see this on cyclones and baghouses and bins. What happens is, if you have an explosion inside a cyclone or a baghouse, you sort of lose control. The explosion has control at that point. And so that cyclone or that baghouse can turn into shrapnel, can turn into a grenade. You send materials outside of that unit. So at the explosion and deflagration venting, what you do is you safely release that pressure. That overpressure will blow out a weak part, explosion panel, something that's replaceable, and it'll direct that force and the energy from that explosion to an unoccupied, safe area. Another way to do it is through containment. So you have a vessel, like a pressure vessel, that's strong enough to contain a deflagration so it doesn't explode. You don't see that too often, but some of your processing equipment, say a hammer mill, is probably strong enough to contain a deflagration inside of it. But most of the time your silos, your bins, those things are not strong enough to contain the amount of pressure we're talking about here. Another type of secondary engineering control is isolation. I mentioned before you can have the flame front propagate between, say, a baghouse and a cyclone. So what you can you isolate that so that that flame front, that deflagration will hit a barrier before it can go to the next unit. So some of the things you'll have, say, a rotary airlock. Most of the time people think of these as just a way of conveying material, but that actually will prevent a flame front from going through because it's a flash fire. It'll hit the vanes in here, and that flash fire won't keep going. You can also have flame front diverters. An example, say a backblast damper, or you'll have a flap valve that if a flame front is coming through here, and instead of going back into the work environment, the flap will drop and the flame will be shot up into the air. Then you have fast-acting valves and chemical isolation. And what those are ways that they'll have detectors in the ductwork, and if it sees a flame front coming, it shuts off that ductwork either with the valve or it'll spray chemical into the ductwork, so when that flame front comes, it hits that chemical and it extinguishes it. Now you can't just rely on engineering controls. Oftentimes engineering controls are expensive. It takes a while to get delivered. It takes a while to get installed. So what should you do first? And make sure you implement those administrative controls. And the most important control out of all is housekeeping. If you keep the dust in the work environment down, then you reduce the potential for that dangerous secondary explosion. So really you want to make sure that housekeeping schedules are sufficient to prevent excess accumulation. You really want to pay special attention to those hard to reach and hidden areas. Also, when you're doing housekeeping, this is important, especially when it comes to training. If you're going to if by doing housekeeping you create a dust cloud, so you create that explosive dust cloud, you want to make sure that all the ignition sources have been locked out, tagged out, have been shut down. You've let things cool down so that when you're cleaning, you don't create a potential hazardous atmosphere that hits the ignition source. You want to make sure you only use rated vacuum cleaners. And also, if you ever use compressed air, you want to make sure you do it with extreme caution. As I mentioned before, make sure things are locked out, tagged out, and make sure you use extremely low pressure compressed air. A lot of places don't even let you use compressed air at all, mainly because it's kind of false cleaning. You blow stuff down. All you're doing is blowing the air off the piece of equipment. You disperse it back into the air. 2 hours later, it's dusty again, and so you're just going around in circles. But there are some ways. If you use it carefully, it might be able to help in some cases. Sometimes you won't be able to get to places without that. But you just got to use extreme caution. If you ever do use compressed air, keep it below 15 psi. Make sure you have lockout, tag out, all your ignition sources. But try to minimize that as much as possible. Also, another important thing is maintenance. You want to make sure that all your bearings and belt alignments are up to speed, because bearings and overheating are large, are a common occurrence. That those are overheating sources. Also, if you have explosion protection, you want to make sure you maintain that. A lot of people don't realize it, but if you have an explosion vent panel on a cyclone, you're supposed to be inspecting that at least annually. And same thing with any suppression systems. Just like your fire extinguishers, you're out there checking your fire extinguisher once a month. You want to do the same thing for explosion protection equipment. So you make sure those are on your PM schedules. And also maintenance, if you have leaks in equipment, you want to address those as quick as possible. Because if you let a leak go on, that just means you're having to do more housekeeping. Finally, make sure all repairs you do, keep the original strength, especially if you're talking about duct work. Duct tape's great for HVAC units, but you don't want to put that on actually conveying lines or dust collection where you have combustible dust, because you don't want to have duct tape, through a piece of duct in your work environment, and all of a sudden that's where the explosions will come out. I wouldn't want to work next to a conveying line that's been sealed with duct tape, because that's where the flame's coming out right there. Safe work practice. We talked earlier about hot work, lockout, tag out. We'll get into hazard communication right now. Really, The new, OSHA has has implemented the new globally harmonized system for hazard communication. Over the next few years, you'll start seeing new labels. They finally, specifically addressed combustible dust and particulates on MSDSs, and or the MSDs. What you really want to make sure is that you've trained all your employees on the hazards associated with dust, or if you are an employee, that you understand, what are the hazards with dust. So you want to know how to recognize unsafe conditions. You want to know the potential consequences of, a dust explosion. You also want to know, okay, well, how to evacuate and when do I evacuate from a potential dust explosion scenario. And finally, supervisors particularly should be trained in the safe startup and shutdown of equipment, because the most often time a dust explosion happens is it's not during normal conditions. It's when something goes wrong. So supervisors need to know, well, how to properly shut down a piece of equipment during an upset condition that won't, precipitate some type of explosion or some type of emergency event. So I'm about to get into a lot of the just sort of regulatory issues. Does anybody have any questions on the basics of combustible dust, the hazard control, hazard analysis before? Yes. Well, first of all, there's some guidance. You can look at OSHA Subpart S, Electrical Safety Standards. What you want to do is you have to classify the areas in your workplace. So you have to say, okay, is it likely that there's going to be a dust cloud or not? And there's some guidance on that. There's NFPA wrote NFPA 499, which gives you guidance on how to come up with what they call hazardous locations. So it's areas where either just during normal operations you're having a lot of dust in the air, or you have a lot of accumulation, or you could have some upset condition that could create a dust cloud in a work environment. So if you have any of those conditions, you're going to want to have a rated fork truck. And the more detailed definitions are in NFPA 499 and the National Electric Code. But if you have an area where, through upset conditions, you could have a dust cloud in a work environment, then you need to have an EE or DE or explosion rated, basically dust type rated fork truck. And they go through what that means. You have enclosed energy sources. You have spark arresters maybe on exhaust, some things like that. But you just look for the EE or EX ratings, or DE, diesel, DE ratings, and other, just a rated truck for that environment. And you can find guidance on that in NFPA and other places. All right, well, I'm going to move on to OSHA standards right now. As I mentioned before, OSHA doesn't have a specific combustible dust rule right now. What they did, they instituted a national emphasis program where they basically gave guidance for inspectors to look for hazards in the workplace, and they gave some training to industry. Instead, what the NEP talks about, it doesn't mention specific combustible dust rule, but it mentions other regulations that are already in place. So it talks about housekeeping regulations. So housekeeping already requires that you keep a clean and sanitary environment. It mentions personal protective equipment. Basically, you're required to do a job hazard analysis, and a dust explosion or explosive atmosphere, it should be included as one of the hazard scenarios that you look at when you're talking about, okay, well, what type of PPE is required here? Do we require flame-resistant clothing? If you're working in a place that has potential vapor clouds, if you're in a refinery, every day you walk in, you have FRC clothes on. So you have to look, are there areas in my work environment where there's a explosive dust cloud, potential for explosive dust cloud? So they mentioned that with respect to personal protective equipment. Also, the electrical standard already addresses, potential for explosive dust in the hazardous classified locations section. And hazard communication, OSHA says you have to inform employees about the hazards that they're exposed to. So if employees are working in areas where you're exposed to dust, fire, dust explosion hazards, they need to know that. They need to be aware that I'm exposed to this type of hazard. But in general, under the National Emphasis Program, OSHA mentions the General Duty Clause. And the General Duty Clause basically says that an employer is responsible for providing a workplace free of recognized hazards. And so OSHA utilizes the National Fire Protection Association, NFPA Standards, to say these are recognized hazards, and so you have to provide a workplace that's free of these hazards, or that you do everything you can to minimize those hazards. In general, here's some pictures showing examples of violations under OSHA's National Emphasis Program. If I was here about machine guarding, I'd have a lot to talk about, but just in general, you got dust up here on a moving piece of equipment and on electrical equipment. So that's a serious housekeeping violation. That was in a wood planer mill, so that's dry sawdust, about 10 or 11% moisture content. Extremely flammable stuff on that belt there. This was at a phenolic resin plant. You can see this was up on a mezzanine, kind of a hidden area. It looks well lit, but that was just like, that was us lighting that. Typically, they didn't go up here. What they didn't realize is that, their rafters had fur. This was highly combustible phenolic resin dust that was just accumulating on these rafters in this overhead mezzanine area. Here's an example of electrical violation. And aside from just the general, you're exposing employees to live electrical parts, this is a dusty environment, and obviously these are not dust-tight equipment. Sad thing about this is I asked them, well, why is that? Why didn't you maintain that electrical panel? Why didn't you, that breaker? They said, well, it was always overheating. That's why they left it open. Yes. Yeah. It depends. There's two different levels. There's dust tight, and then there's dust ignition proof. So it depends on how likely it is. If you can have a dust cloud at that explosive concentration, just as part of, it's a regular occurrence. If you're really dusty environment, like, some places I see maybe at a wood pellet mill where, you're offloading dry sawdust, and every time you dump it off a front end loader, it's just a cloud engulfs the area and you can't hardly see across the room, then yeah, you need the hermetically sealed, very tight equipment. There's different classifications. There's like NEMA 4, NEMA 12 classifications. So you want to have, depending on how likely it is for you to have that dust cloud, you want to have dust tight equipment, and then sometimes dust ignition proof, which basically prevent all overheating of the equipment, depending on how likely it is to have that dust cloud present. Did that answer? Okay. Here's a worker cleaning with compressed air. This is that phenolic resin plant I showed earlier. This plant was hit with, this was near Augusta, Georgia. They were hit with a $350,000 fine from OSHA for combustible dust issues. And this was one of the things. They would do cleaning with compressed air. And when I took this picture, this was about 2 seconds before I ran the hell out of there. But they also, about 10 yards away, they had maintenance going on an energized piece of equipment. So they were not following lockout tagout procedures. They had the control panel open on a piece of equipment, so exposed electrical parts about 10 yards away from where this guy was doing this. So luckily, OSHA stepped in. They've cleaned up their act, but that's just an example of what you do not want to do. Earlier I mentioned the NFPA standards. Really, the National Fire Protection Association it's an agency that's been tasked to come up with standards to help for fire prevention training. They came up with the National Electric Code. They govern, the life safety standards. They come up with fire sprinkler standards. All this. They also have several standards addressing combustible dust. NFPA in itself is not an enforcement body. All they do is they write standards that other people, take those standards and they enforce them. And the people who actually enforce them are called authorities having jurisdiction. Typically, it is your local fire marshal. But technically OSHA is an authority having jurisdiction. Your insurance company is authority having jurisdiction. Anybody who really can reference these standards is an authority having jurisdiction, and they can enforce these rules. Specifically, OSHA uses NFPA standards to really show evidence that industry has recognized combustible dust as a hazard, because some of these combustible dust rules standards have been in place since the 1920s. I think that's when the wood processing standard first came out. It was 1920s. Grain handling, it's almost a century of industry recognizing dust as a hazard. And also, NFPA standards demonstrate a feasible way of minimizing and reducing those hazards. So OSHA says, well, first, hey, this NFPA standards on wood processing shows that the industry knows it's a hazard, and it gives you, reasonable controls that you can put in place, and you've neglected to, install those. So that's what they're issuing citations for. Some of the NFPA standards you might, if you're curious, you want to look up. NFPA 654, that's sort of a catch-all standard. So it's a standard that just addresses almost all combustible particulates. So if you could have combustible particulate solids, that's not covered by a specific industry standard. So if it's not an agricultural food product, metals, or wood processing, you're probably covered by 654. But if you're, say, if you're a sugar refinery, you're going to be covered by NFPA 61. If you're a wood plant, you're covered by NFPA 664. If you're generating aluminum dust, you're under 484. And then there's additional NFPA reference standards that address combustible dust. In general, what OSHA is looking for and what they mention in their NFPA or in their NEP are for dust collector problems. Say you'll have a dust collector located inside, or the return air comes back inside, and you might have, say a cyclone that's exhausted back inside, and it really needs to be 99.9% efficient if you're going to have a return air coming back inside the building from a dust collector. They're also looking for any process equipment where you have an explosion hazard and you don't have any type of protection on it. They're looking for any case where you have ductwork that's not grounded or not conductive, and they're looking for any type of equipment that's connected. And if different pieces of equipment have explosion hazards, you don't isolate that ductwork. That's been a source of fines.
Question.
Yes.
Is accumulation of dust in outdoor areas be the same as indoor areas?
Typically, it's not. I know if I see a lot of places where you'll have loading bins, or you have outside areas around chippers or something like that. You have dust on the ground. Typically, that's not as large a hazard. It's still a fire hazard, still a housekeeping hazard. Your local environmental people probably aren't going to like it, but it's not a big hazard. Just because it's harder to contain that dust cloud, and typically outside areas you're not going to have the exposure to employees as you do inside. Most of the time when we talk about that, you're talking about indoor areas or partially enclosed areas could still be an issue. Here's some example violations based on that OSHA issues based on NFPA standards. So we'll start. This is a cyclone that's located inside. This is off a wood pellet mill. So there's an ignition source that's conveying particulate to this cyclone. You have high concentrations of dust in here. There's no explosion protection. So you have basically a bomb located inside a building where employees are located next to it, and you have no means of protecting. Two, as I mentioned, this goes back to other critical process equipment. This goes back to areas where there are employees exposed. And there's no isolation on this. So there's no way to prevent that explosion, that deflagration, from traveling back to a heavier occupied area. Three, if you remember that electrical box that was open that kept overheating, the reason it was dusty is because that's where the exhaust was. The exhaust from this cyclone went right to that electrical box. And cyclones, it's probably about 80% efficient. NFPA requires 99.9% efficient if you're going to have it vented back inside. So you really typically only see that with bag houses. And most of the time you don't want a bag house inside, you want it outside, but unless you have protection on it. And four, this is a conveying system. It was a dust collection system, but it wasn't grounded at all. There's no grounding on this whole system. So those are four violations that OSHA could have cited them Luckily, they got it fixed. I'm running out of time right now, so I was going to go through what OSHA is doing, but I want to give a little bit of time for to answer some questions. And if you want, I'll be more than happy to send you this presentation so you can see some, what's going on with OSHA's coming regulations. But just in general, they are kind of at a holding pattern right now. They have an advance notice of proposed rulemaking out, issued in 2009. Right now, they have to come up with some type of cost associated with how expensive they think this dust rule is going to cost. And I think their initial assessments are that it's extremely expensive to industry. So because of that, what I've heard is it's moving at a glacial pace. They've had expert forums, they've had stakeholder meetings, they're currently doing research, but we don't think there's going to be an actual rule anytime soon. But again, that doesn't mean you shouldn't address combustible dust hazards now. In general, the next formal step is that OSHA is going to issue a proposed rule, whether that's 2 years or 5 years from now, we don't know. Once that proposed rule is issued, there will be a time for comment period. I can't really say for sure what that's going to have, but if I was a betting man, I would say that it's most likely going to have some type of required administrative and engineering controls. In general, housekeeping and training, I think, are going to be the most important things. Preventing secondary explosions are going to be critical. So housekeeping is going to be a huge part of that. And also employee training and hazard communication will be a big part of that. And it's possible that there's going to be some type of risk analysis required in the ultimate rule. Probably nowhere near, say, process safety management type PHAs, but what I've heard some people say is maybe a PHA light. So it'll be, really toned down from, say, a PSM facility, but still some type of similar components. All right, does anybody have any questions? All right, well, I have some business cards, I have some information. If you want to come get a copy of this presentation, feel free to come see me, give me your business card, pick up mine, send me an email. I'll be more than happy to talk to you about this.